Hello, hello, AB. We're going to do 8.1 integrals as net change. We're in our last unit of topics for AB calculus, which is super exciting. You guys have come a long way. Congratulations. We've just got one more unit to go. So objective here, net and total distance, and then consumption over time. So Roman number one here, net and total distance. So we're going to sketch the region between this curve and the x-axis, which is a curve in of itself, sort of. It's y equal to 0. So let's sketch this. We have a y-intercept of 5. If we factored this, we see that we have x-intercepts then of 1 and 2, 3, 4, 5. Okay, the vertex will be at the middle, so f of 3, which will be 3 minus 5, which is negative 2, and then 3 minus 1, which is 2, so a vertex of negative 4. So, like that. All right, so parabola as to be expected here, and there we go. Okay, so our net area then is going to be the integral from 0 to 5. Okay, so that's your lower and your upper bound right there. And we're just going to take x squared minus 6x plus 5 dx and x cubed over 3 minus 3x squared plus 5x. There we go, from 0 to 5. All right, so this is 125 over 3 minus 75 plus 25. So 125 over 3 minus 50, which is 150 over 3. So we are negative 25 over 3 units. So square here. So we have more negative area, which certainly appears to be the case. So total area, we're going to want to split the integral. We're not on a TI right here, so we're going to have to split the integral. So I want to, you can see that it's going to go from positive area to negative area at 1. So I'm going to write this calculus concept would be from 0 to 1 of f of x, and then this negative area. So you could do a couple of things here. Sometimes, we're definitely going to go from 1 to 5. Okay, and so since this is just one particular area here, you could put the absolute value as on the whole thing. You could just put the absolute values behind here, or you could think of it. I'm going to just show a new technique. This is going to be a negative area, so I want to negate that area. So that's just showing the negation of the area. Or you could say plus the absolute values. They could be on the whole integral because it's just one piece, or even just on the inside here. But so this negative just means to negate the area. Doing the same thing as absolute value. Okay, so this is the antiderivative. We've already found that. From 0 to 1, so 1 over 3 minus 3 plus 5. So that's 2 and 1, 3, 2 and 1 third, or 7 thirds. 7 over 3. And then this one is going to be, we've already done the 5, that's on the paper, so I can just, I can, let's do the antiderivative. We'll just get the value from over here. Okay, so from 1 to 5. All right, so this is minus. I already know this one is going to be negative 25 over 3. And then minus, I already know the 1. So you can use the other parts of the problem to help you. And that's right here, the 7 over 3. Okay, so then this is going to be minus. That's going to be negative 32 over 3. So plus 32 over 3, so 39 over 3, or 13 units squared is the total area. Okay, so once again, just as a reminder, this is displacement, how far we are from the beginning of the problem, and this is total distance. Here, travel. All right, suppose you walk 5 steps to the right. This is also a kind of a review here. 1, 2, 3, 4, 5. and then you take 3 steps to the left. Okay? So the net change, or the displacement, is 2 steps to the right of the start. In this case, I'm not sure what the start is. We'll just assume it's the origin. I don't know. But the total distance traveled is 8. Okay? All right. So that's pretty easy. Suppose v of t squared. Okay, so that's the same graph. Let's graph it again. Noting that that is v of t. All right. And so just answering some questions here. This is just giving application to it. It's the same thing. Okay, so this is v of t, so we're moving right when v of t is positive, and that's occurring from 0 to 1. Left when v of t is negative, and that is occurring from 1 to 5. And then it is stopped when it's at 0, so that's at t equal, v of t equal to 0. And that's occurring at t equal to 1 and 5. All right, net distance traveled, we'd already have done this. So 25 over 3 units to the left, and that's of start. So far start has been the origin, right? So be careful though, it's of the start, and we're about to change that start. So you know, I'm going to start using this word. Start using this word start. Find the total distance traveled in 13 units. Okay, and so notice you know, these would be like feet or what have you. Whereas up here, this is kind of looking at a visual graph. So units squared here, but these would just be units because there's some sort of linear measurement. All right. Okay, so here's just a little box for us. Net distance traveled displacement change from original position is just the definite integral from A to B of our velocity. Okay, and then total distance traveled is the absolute value of velocity. From A to B. Okay, suppose you start, so here we go, we're changing our start. We're going to start 5 steps to the right of your house. We're going to go 6 steps to the right, and then 8 steps back. All right, so notice how this changes. The net distance traveled, okay, so the net distance traveled is 2 steps to the left, and that's of start. Okay, the total distance is what? We went 6 and 8, that's 14 steps total, and the final position is 3 steps to the right, you know, of the origin. Okay, so just a different way to think about it. So final position, we're bringing this in here. Final position is the initial plus the displacement. So that should look very familiar to you guys when we have to reveal a f of x. Remember, we had that initial given point from those FTC problems, and then of course a definite integral here. And I guess we're doing v of t here, so maybe we'll change this to s of t. So that looks familiar. Should look familiar. Oh, and here it is right here. I just rewrote something that is already in the notes. So this is just showing position from A to B, which is then s of b minus s of a. Okay, and so this s of b then here, if we were solving for this s of b, this would be the final position this S of A would be this initial, that lower bound. That lower bound plug in that y value, and then this definite integral. So same thing that I just wrote over there. Okay? And this is displacement. Okay, so let's do an example. Going along the x-axis in inches, initial position at 0 is 5 inches. Okay? Graph of velocity, check that out, always check. The numbers are areas of the enclosed regions. Answer using complete sentences. Include appropriate units in calculus for reasons. Okay, so the displacement then is simply 0 to d of the velocity graph. dt displacement, not position. And so this is going to be, since I have a visual, this is area under the curve, so I can just go to my numbers. Negative 10 plus 6 minus 2 plus 9. So negatives below, positives above, easy peasy. So what's this? Negative 4 plus 7. Looks like we get 3 inches. Inches right of start, which is 5 inches. What is the total distance? Okay, so this one says I have 2 negatives here. I want to be careful and just go here. I want to make sure I do the absolute value. So if you did the absolute value of the whole integral, you can see how the whole integral is 3. Absolute value of that would be 3, but that's not going to be right. So you're going to want to make sure you show the calculus concept with the AV back here. Okay, and so this will just be 10 plus 6 plus 2 plus 9. Okay, so here we're going to get 16 plus 11, 27 inches total traveled. And then now what's the position? Okay, so position, still the S, the S is a position, but now we have an initial, we're changing from starting at origin to starting at 5. So at A, we're going to go 0. We're going to go 0 to A of V of t dt. Okay, so we don't do absolute values there because it's displacement, and then we're going to make sure we add in that plus 5. Could be in the front or in the back. And so that's going to be negative 10 plus 5. So we are negative 5. Okay, so 5 inches to the left of the origin. All right, and then at here, 0 to d, v of t dt plus 5. So we've already said that this was 3 plus 8. Or sorry, got ahead of myself. 3 plus 5 is 8. We already got that was 3. Add in that 5, 8 inches to the right of the origin. All right. Where does the particle have its greatest positive acceleration? So acceleration is slope of velocity and that appears to be greatest. The greatest slope here looks to be about right at this POI right there. Say T equal to A. All right, next page says rocket is fired straight up from ground level with a velocity of 800 feet per second. The acceleration due to Earth's gravity is 32 feet per second. Okay, so that means that A of t is, gravity pulls downward, so it's negative 32. Let's kind of know that. Looks like we're at ground level, and initial velocity is 800. What's the velocity of the rocket after 5 seconds? So let's find velocity. V of t will be the integral of acceleration dt. So V of t be integral of negative 32 dt. V of t will be negative 32t plus a constant. Initial velocity is 0. So that was 800. So that's our C. All right, so V of t formula is negative 32t plus 800. All right. And then just find that at 5. Okay, and so this is what, negative 160 plus 800, 640 feet per second. Okay, when does the rocket hit the ground? Okay, so when is its position? 0, so I need to find position. Okay, you'll see this sometimes. Maybe call this to t plus, say C sub 1. I don't know. C sub 1. That's not a big deal for me, but we'll just follow directions. Initial position of 0. So S of 0 is just 0. Right, and that was 0. So let's just save some room here. So C is 0. All right, so position is negative 16t squared plus 800 t. Where does this hit the ground? At t equal to 0, which makes sense. We started on the ground, so at 50 seconds. This should seem like review to you guys. When it hits the ground, what is the total distance traveled? All right. Okay. Not on a calculator, so I got to see if we have positive and negative distance at time. All right. And total distance. Okay, so I'm going to want to integrate velocity. Absolute. Well, I'm going to. Maybe we'll just leave it like this for a second. Let's look first before we. Okay, so let's graph this thing right here. Let's graph V of t equals negative 32t plus 800. All right, so 800, and we are graphing from 0 to 50 when it hits the ground. 50 equals 50 seconds. Okay, if I put 50 in here, to get 50 in here, we're going to get that same amount of space. All right, you'll see that we get, if you do negative 32 times 50 plus 800, we're going to get negative 800. That's the same amount of space. Okay, so we have this point and this point. Okay, so we are going to have some negative distance there. So we're looking at this positive distance, this negative distance, right? Okay, and so to show the calculus concept, we want to see what this is. So we'll set this to 0. Okay, and so we get 32t equaling 800, and divided by 32, just get 25. Well, that was negative, right? But just take positive 800 divided by 32, you get positive 25. All right, t is 25. Okay, so what we want to do here then is go from 0, and you can see some symmetry here. You'll see that play out. We want to go 0 to 25 of v of t dt, and then let's negate the negative area and go 25 to 50 I think that's just cleaner than those absolute value symbols here. All right, and let's just show this in action here. So v of t integrates up to negative 16 t squared plus 800 t from 0 to 25 minus negative 16 t squared plus 800 t from 25 to 50. All right, so let's do this. Let's go ahead and put 16, negative 16x squared plus 800x there. Okay, and let's retrieve it. And 25, okay, we're going to get 10,000. All right, so this first is 10,000 minus 0 minus, okay, let's put 50 in there. Okay, that's 0. And then minus the 25, which is 10,000. All right, and so this is 10,000 minus 10,000 plus 10,000, 20,000. When the rocket hits the ground, it has traveled a total of 20,000 feet. All right, so answer parts B and C. Answer parts B and C as an example 2, but this time assume initial position is 50 feet above the ground. Set up the problem and use your TI to calculate. Show use of the FTC to set up and find the rocket's position after 30 seconds. Okay, so we can do this. So 2B again with an initial position of 50. So that is just going to be when we put an S of 0 now, and we're at negative 16, 0 squared plus 800, 0 plus C. Now we know that's 50. So C is 50. So S of T here is negative 16 T squared plus 800 T plus 50. And so when does this hit the ground? So let's see when this hits the ground. Let's put it in here. Oh, yay, it's already there. It's at 50. Okay, and let's do, we got this was 50 seconds, so if we start at an initial position 50 feet above the ground, it's going to take a little longer to hit the ground. So let's think about our window. Be smart, clear. Now let's do zoom 7, so I don't really want to graph it. But let's change our window. Okay. I did a zoom 7 from pre-cal. Sorry, let's do a zoom 6. Get everything back to standard. And then go to my window. And so let's go from 0 to something bigger than 50. I don't know, 75. Let's just see what that looks like. I don't really care if I see the curve. Yeah, that's what I want to see. And you know what I like to do sometimes? I like to put another curve in there, and it's a second trace intersects a little easier. So I'm going to intersect these instead of finding the zeros. But so second trace, here we go. Second trace, there we go. Intersect 1, 2, 3. Okay, so that says what? 50.062. Okay, so I think that has covered part 2B. And then 3B with 50. Let's see, what do we have to do on 3B? No, 2B, no. 2C, good grief. 2C, all right, 2C. When it hits the ground, what's the total distance traveled? Okay, so get to use the TI, fantastic. So we're just going to go 0 to 50.062. And 422, I'm going to go ahead and grab it all so it's precise. And this time I'm going to do V of t here, dt. Okay? All right, and so let's plug that in. Let's just go here, negative 32t plus 800 was our v of t. All right, so quit, and let's go to clear math 9 of math number abs for absolute value. Let's grab our function, which we have variable function here, which we defined in y3. Okay, close that, x, close that, 0, but 50.062422. All right, and so we get this total distance is 20,049.969 feet. A reasonable answer, right? It should be similar to this one, but a little longer to hit the ground because you started higher. Makes total perfect sense. Okay, show the use of FTC to set up and find the positions rocket after 30 seconds. Okay, so let's do that now. Okay, so super easy. We already have our position function right here with the initial position in there. So S of 30 is just, you know, you go to your calculator. We already have that assigned in there, right? First one. What am I doing? Oh, I just messed it up. Okay. 30. Oh gosh, I messed up, don't I? Because it's negative. Okay, so let's try that again. There we go, 9650. Okay, so that's the new question at 30. But it says that they want to see it as an FTC integral. So S of 30 would look like this. Okay, so we want to go 0 to 30. V of t dt plus 50. Okay, so let's see that. Here, math 9. Which one's my v of t? This y3. So dim, I can't see. It's really bright on up there, but it's dim when I'm trying to look at it over here. 0, 30, plus 50. Yay, 9650. There you go. So there's two little options for you. This is obviously how I would do it since we found that in 2B, but this is using the FTC, that new skill that we are kind of hammering over and over and over. Okay, so next two pieces here. Try to go through these more quickly. All of these problems are the types where the graph compares the rate of change in time. All right, so fuel consumption for cities modeled by this following equation. So that'll be 4.7 here, exponential. Area in the curve can be thought of as the sum of many little rectangles. Okay, we'll talk about this in a second. I think I jumped ahead of myself. We're going to begin in 1987, and we're going to go from 91, that's 4 years, and to 1999. Okay, so that is going to be 12 years. So on our graph, we'll go 4, 8, 12. Okay, so we're looking here to here, this area here. So this can be thought of, you know, lots of little rectangles here that we're going to sum up, right? So this area, all these little rectangles. And so this is time, all right, in years. And this is C of t, which is thousands of gallons per year. So when we integrate, since these are rectangles, you'd multiply unit by unit, and thousands of gallons per year times year would be thousands of gallons is going to be the unit once we integrate. So these dimensions are gallons per year in thousands and year, and so these area, when all is said and done, will represent gallons, and that's of course in thousands. Got to read everything super careful. Okay, so let's do this. Let's go from 4 to 12. 3.7 e to the 0.3 t dt. All right, and let's integrate. It's plus sign, huh? Plus 3.7 t plus e to the 0.3 t. This would have a u sub. So this is going to have a 10 over 3 in front, okay? 10 over 3 in front. Oh, I'm looking at that as a 1. Sorry, not a 3. Okay, 0.1, which is 1/10, 0.1, and so 10. From 4 to 12. Okay, so this is going to have a TI now. 3.7 times 12 plus 10 e to the 0.1 times 12 minus 3.74 plus 10 e to the 0.1 times 4. Put that in parentheses. Okay. And when we calculate all of this good stuff, I won't go through all of that, but you would just plug this into your TI, and let's see what we get here. Just looking at my notes. Should be 47.883, and that's 1,000 gallons. You go to your TI at this point. You could even say 47.3 gallons. All right. Good. Okay, sorry about this little mix-up here. My eyes aren't as good as they should be. Wow, that is actually does kind of look like a 1 from far away. Anyway, all right, next one. This one's harder, but not really. The function v of t, 5 sine squared cosine t, is the velocity of in meters per second of a particle moving along the t-axis on the interval 0 to 2. Sketch the graph. Recognize you can identify the zeros of vt analytically. All right, so here we go. 2 pi, bring in some pre-cal. Okay, so let's see. When is this going to be 0? When is 5 sine squared of t cosine of t going to be 0? Well, anytime cosine 0, right? By zero product property of cosine is 0. So there and there. Okay, and then whenever sine is 0, it's just going to, and squared, it's going to be here, here, and here. Those are going to be our zeros. Okay, and you know, then we're going to graph it. I mean, you could sort of think about, just a reminder, in quadrant 1, sine and cosine are going to be positive, so this is going to be above. So this is, I guess this is the region testing piece here. Quadrant 1, everybody's positive, so it'll be above. Quadrant 2, sine's going to be positive, cosine's going to be negative. Quadrant 3, that's going to be positive. They'd both be negative, but that's squared, right? So this is going to be negative. That'll be positive, negative. And then cosine's positive. Sine's negative, but it gets squared, so positive. So I'm going to be above, below, below, and above. So let's just now go to graph. Clear, clear, clear. What do we have here? 5 sine of x, close that, square that, cosine x, close that. All good. And let's do it zoom 7. Okay, nice little symmetrical graph here. So So, determine when the particle is moving to the right. Okay, well this is v of t. So we are moving to the right from when v of t is greater than 0. So from 0 to pi over 2 union 3 pi over 2 to 2 pi. To the left, pi, oops. If you are inclined to include, to use closed intervals, you could just make this 1. If you're, I think of that as a stopping point. But if you are one that uses brackets, you could just write this as 1. Stopped here, and sorry, this is v of t less than 0, and this is v of t equal to 0. So this is 0 pi over 2 pi 3 pi over 2 2 pi. Okay. Suppose we could write this as pi over 2n. Yeah. Okay. Find the particle's displacement. Okay. Perfect. Easy. Straight up integral. Not a lot to think about. Kind of like that word, displacement, because you don't have to think too much. 5 sine squared of t cosine of t dt. We got a u sub t up right here for sine of t. du is cosine t dt. All right, let's change our upper and our lower. So 0 and here is 0, 2 pi. Ooh, look at that. We have an integral from 0 to 0. So we are 0. Okay? Don't even have to go through it. We are 0. And you can kind of see that based on the symmetry in the graph. You can predict that the displacement will be 0. All right. So let's now do the total distance. Okay, so let's go the integral from 0. You can pi over 2. I'm going to speed this up here. 5, take that out. I've already started this u sub piece here. So let's adjust here. Well, maybe I won't skip that step. So this is sine squared of t cosine of t dt. All right. So now let's do 5, 0 to 1 with this u sub. All right, and so this is going to be u squared du. So 5 here, and let's integrate. This will be u cubed over 3 from 0 to 1. So this will be 5 over 3 here. All right? Okay, so 5, 1 over 3. Of course, minus 0. So this is 5 over 3. All right, so that's the first one, and you're going to see, this displacement was 0, so these have to be equal areas. So this is actually going to end up being 5 over 3, 5 over 3, 5 over 3. So we could multiply that by 4 and get this. But let's just be good people. Do this, do this, do this, and do this. Let's do the next integral, okay? And let's go from pi over 2 to pi, u squared du. And then let's do pi, 3 pi over 2, u squared du. And then 3 pi over 2 to 2 pi of u squared du. Okay, so upper and lower here are going to need to be changed. So this is going to be 1 to 0. This is going to be 0 to negative 1. And this is going to be negative 1 to 0. All right. So this is uncomfortable. Switch that. All right, and this will be u cubed, and these all have a 5. So this will be u cubed over 3, again, times 5, and this is going to go from 0 to 1. These are uncomfortable. Okay, and so this is going to be minus 5 u cubed over 3 from negative 1 to 0. And these are uncomfortable, so we're going to negate that. Oh, I guess I should negate it. I did it here. Anyway, this is here, and 0, or sorry. Oh, this one's not uncomfortable. What am I saying? This one's fine. All right, so this is just going to be 5u cubed over 3 from negative 1 to 0. Phew. Okay, so this will be negative 5, and this is going to be 1 over 3. But this is total, so I'm going to, I negated the integral, but then this is a negative. So I want to go ahead and go back and do the absolute value of, which is going to be the opposite of, so I get 5 over 3. Okay? And then this one's going to be the same thing. This is a negative integral, so I'll actually change that to positive because it's below, right? And so I want the absolute value, so I'm going to use that with the negative. So change that back to a positive, and then we've got 0, and that goes in, minus 5 times this negative 1 goes in for negative 1 over 3. So perfect. We get another 5 over 3. So as predicted, we got 4 of these things. I just, symmetry sort of showed that, but I just showing you the math that backs it up. And last but not least, this one was comfortable, so we get 0 popping in there, and then minus this 5 times negative 1 over 3. Once again, that's positive 5 over 3, so total distance traveled here is 20 over 3 units. And that's it. All right, there you go. Okay, so that's 8.1 for you, and I'll see you in class next time. All right, bye guys.